Okay, so we are done with the first step of urine formation, that is glomerular filtration. That brings us to the second step of urine formation, and that is reabsorption. So here we will observe that how from the filtrate maximum amount of water and essential substances can be reabsorbed into our system. So a comparison of the volume of the filtrate formed per day, that is 180 liters, with that of the urine release suggests that nearly 99% of the filtrate has to be reabsorbed by the renal tubule. We know that 180 liters of blood is actually filtered by the kidney, and what is the amount of urine formed? It's nearly 1% or less than 1%, right? So out of 180 liters, only 1.5 liter of urine is actually formed. So what does that say? It says that 99% of the filtrate, right? 99% of the filtrate is reabsorbed by the renal tubules, and this step or this process is called reabsorption. So let's understand how exactly reabsorption occurs in urine formation. So the main part of the nephron which is responsible for the reabsorption process is your PCT, to some extent your Henle's loop, your DCT, and the collecting duct. So the tubular epithelial cells in different segments of nephron perform this either by active or passive mechanism. We know that the nature of renal tubule is made up of epithelial cells. So the tubular epithelial cells in the different segments of nephron will absorb the nutrients either by active or passive mechanisms. For example, substances like glucose, amino acids in the filtrate are reabsorbed actively. So you know that what do you mean by an active process? In an active process, there is always an expenditure of energy or ATP molecule, whereas the nitrogenous waste are absorbed by passive transport. So in reabsorption, what did we observe? In reabsorption, we observe that the tubular part of the nephron is mainly concerned with the maximum absorption of water, nutrients, as well as salt. Now that brings us to the last step of urine formation, and that is tubular secretion. So during urine formation, the tubular cells secrete substances like hydrogen, potassium, and ammonia into the filtrate. Okay, so tubular secretion is also an important step in urine formation, as it helps in the maintenance of ionic and acid base balance of body fluids. So secretion is step, that is tubular secretion, is very important, because you know that the urine has got a particular pH, right? So to maintain the pH as well as the ionic acid base balance of the body, this step, that is tubular secretion, is very important. So here you can see how the substances from the filtrate is actually getting back into the system through the peritubular capillaries. So now let's have a look at the function of the tubules, which is the next topic for our discussion. So first let's see how proximal convoluted tubule plays its role. So PCT basically consists of simple cuboidal brush bordered epithelium. Just like we observed the brush bordered epithelium in case of your small intestine, that is a villi. So similarly here we observe that the PCT is lined by simple cuboidal brush border epithelium, which increases the surface area for reabsorption, right? Because reabsorption is a very important step, and in reabsorption an active player is your PCT, right? So nearly all of the essential nutrients and 70 to 80% of the electrolytes and water are reabsorbed by this segment. So if you have a look here, the percentage of reabsorption is maximum in PCT. Okay, so maximum amount of reabsorption process occurs in the PCT. So PCT also helps to maintain the pH and ionic balance of the body fluid. Now moving on to Henle's loop, let's see what's the role of Henle's loop. Reabsorption in this segment is minimum. Okay, Henle's loop plays the least role. If I said PCT is doing the major task of reabsorption, Henle's loop does the least. However, this region plays a significant role in the maintenance of high osmolarity of medullary interstitial fluid. So this maintenance of high osmolarity of medullary interstitial fluid is very, very crucial when we'll be discussing the concentration of urine, okay, through a mechanism called as counter current mechanism. So during the counter current mechanism, we are going to observe how Henle's loop and the vasa recta helps in maintenance of high osmolarity of medullary interstitial fluid. So if we try to define osmolarity, what is osmolarity? It is a total solid concentration of a solution. Okay. Now, coming back to the Henle's loop, the descending limb of loop of Henle is permeable to water, but also almost impermeable to electrolytes. So if we have a look at the descending loop of Henle, right, when we study the loop of Henle, we find that it has got a descending limb and it has got a ascending limb. So what is the characteristic of the descending limb of loop of Henle? It is permeable to water, but almost impermeable to electrolytes, that is the salts. This concentrates the filtrate as it moves down. Because the water is being lost from the filtrate, the overall concentration of the filtrate increases, right? Because the salt cannot move, cannot escape the descending limb, but it is permeable to water. So the ascending limb is impermeable to water, but allows transport of electrolytes actively or passively. Therefore, as the concentrated filtrate passes upward, it gets diluted due to the passage of electrolytes to the medullary fluid. So when we'll be discussing the mechanism of concentration of urine, you will have a better understanding. So for time being, remember that the descending limb of loop of Henle is permeable to water. At the same time, the ascending limb is impermeable to water. Okay. Now let's move on to the collecting duct. So this long duct extends from the cortex of the kidney to the inner parts of the medulla. Large amount of water could be reabsorbed from this region to produce a concentrated urine. Okay, so the major task of reabsorption of water should happen in the collecting duct. So large amount of water could be reabsorbed from this region to produce a concentrated urine. So this segment allows passage of small amount of urea into the medullary interstitium to keep up the osmolarity. It also plays a role in the maintenance of pH and ionic balance of blood by the selective secretion of hydrogen and potassium ion.